In the heart of our solar system, Venus is a stark warning, a world so inhospitable that human exploration remains impossible. Its surface temperature reaches 870 degrees 465 degrees Celsius, with atmospheric pressure over 90 times Earth's, creating a toxic environment of carbon dioxide and sulfuric acid. This hostile landscape offers a chilling glimpse of Earth's potential future if climate change spirals out of control. So before we go deeper, hit like, subscribe, and tell me in the comments what you think this really means. And if you want to help this message reach others who still wonder, share it on X, Facebook, Reddit, or even just in your group chats. You're the reason this search is alive. Thank you for keeping your eyes open. 50 years ago, the Soviet Union launched the Venera missions to study this inferno. These probes, engineered to endure Venus's extremes, carried instruments to analyze the surface and atmosphere. Early attempts often failed, but on December 15, 1970, Venera 7 successfully transmitted 23 minutes of data, revealing a rocky, barren terrain instead of the expected molten lava. Subsequent missions built on this breakthrough. In 1975, Venera 9 and 10 returned the first images of the Venusian surface, showing a desolate landscape of jagged rocks. By 1982, Venera 13 and 14 captured color images and analyzed soil samples, hinting at active volcanic processes and raising questions about Venus's past habitability. Called Earth's evil twin, Venus shares similarities in size and composition, yet it has evolved into a radically different world. The Venera missions revealed how runaway climate change can transform a once temperate planet into an uninhabitable wasteland. This story of ingenuity underscores the fragile balance sustaining life on Earth. The Venera missions embody human curiosity in the face of immense challenges. As climate change intensifies, the lessons of Venus grow more urgent, and its fiery fate may hold the key to understanding and avoiding a similar destiny for Earth. Part 1. The First Descent. Just how difficult is it to land on a world that wants to destroy you? In 1961, the Soviet Union began the Venera program, aiming to pierce the veil of Venus's clouds. At the time, scientists believed Venus might harbor a temperate climate, perhaps even oceans. They were catastrophically wrong. On October 18, 1967, Venera 4 became the first spacecraft to enter another planet's atmosphere. As it descended, the readings were encouraging, until they weren't. Temperatures soared to 250 degrees, hot enough to melt lead. Pressures crushed the probe, still kilometers above the surface, at a staggering 75 to 100 times the pressure found at sea level on Earth. The mission failed, but not before sending a chilling message. Venus was no paradise. It was a furnace. The data Venera 4 transmitted in its final moments painted a grim picture. The atmosphere was not the thin, breathable layer scientists had once imagined, but a dense, choking shroud of carbon dioxide laced with corrosive sulfuric acid clouds. The surface, obscured by perpetual storms, was a mystery, but the conditions above it were already a nightmare. The probe's thermometer maxed out at 262 degrees C, while the pressure gauge registered 180 times the atmospheric pressure of Earth before failing. The spacecraft, designed to withstand harsh conditions, lasted only 94 minutes in this alien hell. Yet the Soviets persisted. They rebuilt their spacecraft, turning them into armored titanium spheres designed to withstand crushing pressures and infernal heat. The challenge was monumental: survive long enough to send back meaningful data before the hellish conditions destroyed everything. Engineers added reinforced heat shields, thicker walls, and more robust instruments, all to buy a few more precious minutes of survival. Venera 5 and 6 followed in 1969, each equipped to endure longer but still falling short of reaching the surface intact. Their parachutes deployed in the thick atmosphere, slowing their descent, but the crushing pressure and searing heat overwhelmed them both. The Venera program became a testament to human tenacity in the face of the unknown. Each failure was met with a new design, a new strategy. Venera 7, launched in 1970, was the first to reach the surface, though its signal cut out after just 23 minutes. The data it sent back was fragmented but groundbreaking. The surface temperature exceeded 420°, and the pressure was over 90 times that of Earth's. The Soviets had achieved the impossible, but the victory was bittersweet. Venus had claimed another casualty, and the quest for answers was far from over. But why go to such lengths for a world so hostile? The answer lies not just in scientific curiosity, but in a warning, one that echoes across 40 million kilometers of space. Venus may hold the key to understanding the delicate balance of life and death on Earth. Its atmosphere, choked with greenhouse gases, offers a chilling preview of what could happen if Earth's climate spirals out of control. The planet's runaway greenhouse effect, driven by a thick blanket of carbon dioxide, has transformed it into a scorching wasteland. The surface, eternally shrouded in darkness, is a graveyard of failed missions, a testament to the fragility of habitable worlds. Observation. The Venera program's early failures were not merely technical setbacks, they were revelations. Each probe that succumbed to Venus's inferno provided a clearer picture of a world pushed to the brink by climate catastrophe. The carbon dioxide-rich atmosphere, with its crushing pressure and acidic clouds, served as a stark reminder of the consequences of unchecked greenhouse gas emissions. Interpretation. Venus, once thought to be Earth's sister planet due to its similar size and composition, now stands as a cautionary tale. Its proximity to the Sun, combined with its thick atmosphere, has led to a runaway greenhouse effect that has rendered it inhospitable. The lessons learned from the Venera missions have profound implications for Earth, highlighting the delicate balance required to maintain a habitable climate. Speculation. Could Venus have once been habitable? Some scientists theorize that billions of years ago, the planet may have had liquid water on its surface, a crucial ingredient for life. However, its closeness to the Sun and the subsequent build-up of greenhouse gases likely tipped it into the inferno we see today. Understanding Venus's past could offer insights into Earth's future and the fragility of planetary climates. Part 2. Into the Abyss. Imagine a place where the air behaves like liquid, temperatures exceed those of molten lead, and pressure can crush a submarine. This is Venus. After Venera 4's failure, the Soviets launched Venera 7 in 1970 to reach the surface and transmit data. The probe was reinforced to withstand 180 atmospheres of pressure, with a modified parachute system for rapid descent. Shell, a fortress of titanium, was designed to endure the inferno for as long as possible. On December 15, 1970, the descent module entered Venus's atmosphere, The parachute deployed but tore apart roughly 3 kilometers above the surface, sending the probe into freefall. It hit the ground at 17 meters per second, landing on its side in a violent collision. Weeks later, engineers detected a faint signal. Venera 7 had transmitted data for 23 minutes, marking the first successful transmission from another planet's surface. That faint, intermittent signal was a triumph, a whisper from the edge of human achievement. Venera 7's data was astonishing. The temperature was a staggering 465 degrees with surface pressure at 90 atmospheres, nearly a kilometer deep in Earth's oceans. Venus was revealed as a hellish world pushing the limits of human technology. The numbers were almost incomprehensible. Temperatures hot enough to melt lead, and pressure that would vaporize a human body in seconds. The data painted a portrait of a world that seemed designed to destroy anything that dared to venture into it. The Soviets were undeterred. They launched Venera 8 in 1972, equipped with improved sensors and a stronger heat shield. It transmitted data for 50 minutes, confirming temperatures of 470 degrees and 90 atmospheres of pressure. Despite its brief lifespan, Venera 8 provided valuable insights into Venus's atmosphere and surface. Its sensors detected a landscape of jagged rocks and volcanic plains, hinting at a world shaped by relentless geological forces. The faint whisper of Venera 7 had grown louder, but the message remained the same. Venus was a crucible, a test of humanity's ingenuity and resolve. Observation, Venera 7 and 8 reshaped our understanding of Venus. Its extreme conditions ruled out liquid water or life as we know it. The probes had descended into a world that seemed to defy the very concept of habitability, a stark contrast to the hopes once held for Earth's sister planet. Speculation. Scientists wondered if Venus had always been this way. Had it once been more hospitable, only to succumb to a runaway greenhouse effect? These questions sparked renewed interest in Venus as a cautionary tale for Earth. The spectre of a world consumed by its own atmosphere loomed large, a warning of what unchecked climate change could bring. In 1975, the Soviets launched Venera 9 and 10, each carrying a lander to photograph Venus's surface. Engineers innovated ways to protect delicate electronics from the crushing pressure and heat. On October 22, 1975, Venera 9 transmitted the first images from another planet's surface, revealing a desolate, rocky landscape. The grainy, sepia-toned images were a stark testament to the harsh reality of Venus, a world of fractured rocks and choking haze illuminated by a dim, diffused light. Venera 10 followed on October 25th, sending similar images, further confirming the desolation. The cameras, designed to operate for mere minutes, captured glimpses of a world that seemed frozen in a perpetual fiery twilight. Observation. The images showed a barren, inhospitable landscape with rocks and boulders shaped by unknown processes. The thick atmosphere filtered sunlight, casting an eerie glow. Volcanic rocks hinted at a geologically active world, where tectonic forces and eruptions constantly reshaped the surface. The faint light that reached the surface was a testament to the atmosphere's density, a suffocating blanket that trapped heat and blocked the stars. Interpretation. Data and images from these missions depicted Venus as a world dominated by extreme conditions, with a carbon dioxide-rich atmosphere trapping heat. Venus was a stark reminder of how a planet's climate could spiral out of control. It was a mirror reflecting the fragility of Earth's own climate, a warning of what could happen if the delicate balance of gases and temperatures tipped too far. The abyss of Venus was more than a physical place. It was a window into the potential fates of worlds, including our own. The Soviets' relentless pursuit of knowledge about Venus laid the groundwork for future exploration, a legacy of daring and discovery that continues to this day. Each mission refined technology and deepened understanding, pushing the boundaries of what humanity could achieve in the face of the cosmos's most unforgiving challenges. Part 3. The First Glimpse. On June 8, 1975, Venera 9 touched down on Venus, marking a monumental achievement in space exploration. This mission represented a complete redesign of Soviet spacecraft, featuring a robust titanium hull surrounded by 12 centimeters of thermal insulation to withstand the planet's hellish conditions. Its camera system, equipped with periscopes, allowed it to capture images despite the crushing atmospheric pressure. The lander transmitted the first photograph ever taken from the surface of another planet, a grainy yet astonishing glimpse of an alien world. The image revealed a desolate landscape of sharp-edged rocks and a murky yellow-orange sky, shrouded in perpetual twilight due to the dense sulfuric acid clouds that obscure sunlight. The lander operated for 53 minutes, a remarkable feat in temperatures exceeding 860 degrees C, 460 degrees C, before succumbing to the heat. But the mission wasn't ended by thermal failure. It ended because the orbiter relaying the signal moved out of range, a poignant reminder of the technical challenges of exploring such a hostile environment. Venera 10 followed 5 days later, landing on the opposite hemisphere of Venus. It too transmitted images for 65 minutes, providing scientists with a broader view of the planet's surface. For the first time, humanity could see what Venus looked like, and it was nothing like anyone had imagined. The rocky, volcanic terrain was a stark reminder of the planet's violent past, shaped by catastrophic events that reshaped its surface. The images revealed vast lava plains, fractured bedrock, and slabs of layered material, hinting at a history of tectonic activity and volcanism. But the most striking feature was the absence of small craters, suggesting that the surface was relatively young, perhaps only 500 million years old compared to Earth's 4.5 billion-year-old crust. The real breakthrough came with Venera 13 and 14, launched in 1981. These landers were even more advanced, carrying color cameras that sent back vivid, almost surreal images of a brownish-orange landscape. The rocks appeared weathered, not by wind or water, but by the corrosive effects of the thick, acidic atmosphere. The landers also drilled into the surface, analyzing soil samples with onboard X-ray fluorescence spectrometers. The results revealed a composition rich in potassium, magnesium, and chlorine, a stark contrast to the iron-rich soils of Mars or the Moon. The sounds recorded by the landers were eerie and unsettling. A low, rumbling wind, mechanical clunks from the spacecraft, and the constant hiss of the Venusian atmosphere, a symphony of an alien world. But the most intriguing discovery was the composition of the rocks. Basalt, similar to volcanic rock found on Earth's ocean floors. This suggested that Venus, like Earth, had experienced large-scale volcanic activity in its past. However, the lack of plate tectonics on Venus meant that its heat was not recycled efficiently, leading to a build-up of internal pressure. Scientists speculated that this could result in catastrophic resurfacing events, where vast amounts of lava erupted simultaneously, reshaping the planet's surface in a matter of years. Venus, it seemed, had a geological history not unlike our own, but one that had taken a far more violent and destructive path. The images and data from the Venera missions challenged long-held assumptions about Venus. Early astronomers had imagined it as a lush, tropical paradise hidden beneath its clouds. Instead, the Soviet landers revealed a world of extremes: a surface hot enough to melt lead, an atmospheric pressure 90 times that of Earth, and skies filled with sulfuric acid rain. These conditions raised profound questions about the planet's evolution. How did Venus, once thought to be Earth's sister planet due to its similar size and composition, become the inferno we see today? And what lessons could this hold for our own planet's future? Observation. The Venera missions revealed that Venus's surface is relatively young, suggesting it has been reshaped by global volcanic events in the last 500 million years. Interpretation. The lack of plate tectonics on Venus may lead to periodic, catastrophic resurfacing, where vast amounts of lava erupt and solidify, wiping out older features. Speculation. If Venus once had oceans, as some models suggest, the runaway greenhouse effect that boiled them away could have been triggered by such a resurfacing event, releasing enormous amounts of carbon dioxide into the atmosphere. This hypothesis remains controversial but highlights the delicate balance required for a planet to maintain habitable conditions. Part 4. The supercritical ocean. At Venus's surface, carbon dioxide isn't quite a gas. It's something else, a supercritical fluid. Above a critical point of 73 atmospheres and 304 Kelvin, carbon dioxide becomes a substance with properties of both a liquid and a gas. It can dissolve materials like a liquid but flows and expands like a gas. This supercritical ocean covers Venus's surface, distributing heat so efficiently that the temperature barely changes between day and night. The scorching heat, hovering around 735 Kelvin, 460 Serda, ensures that this dense, choking atmosphere remains in a state of perpetual flux, a relentless storm that never abates. The pressure at the surface, roughly 90 times that of Earth's, crushes down on this supercritical fluid, making it denser than water and capable of behaving in ways that defy our terrestrial understanding of gases. Some researchers suggest that this supercritical ocean may have once been even more liquid-like, carving channels and shaping the planet's surface. Computer models indicate that under certain conditions, clusters of gas-like bubbles could have formed, creating structures resembling soap bubbles covered in a thick layer of liquid. These bubbles, if they existed, might have created ephemeral patterns on the surface, visible only for brief moments before collapsing under the immense pressure. Imagine a world where carbon dioxide flows like lava, sculpting the landscape into alien forms. While this remains speculative, the idea that Venus once had seas of liquid or near-liquid carbon dioxide is scientifically plausible. Observation. Radar imaging from NASA's Magellan mission in the 1990s revealed vast lava plains, towering volcanoes, and sinuous channels on Venus's surface. These channels, some stretching thousands of kilometers, hint at a past where fluid, possibly supercritical carbon dioxide, flowed freely, shaping the planet's geology. The longest of these channels, Baltis Vallis, extends over 6,800 kilometers, longer than the Nile River on Earth. If these channels were indeed carved by liquid carbon dioxide, They would represent the remnants of a time when Venus was a dynamic, active world, far removed from its current stagnant state. But how did Venus transform from a potential ocean world to the hellscape it is today? The answer may lie in the planet's geological activity, or lack thereof. Venus, unlike Earth, has no plate tectonics to recycle carbon dioxide back into its rocks. Without this mechanism, the planet's atmosphere has become a runaway greenhouse, trapping heat and escalating temperatures to catastrophic levels. The last major volcanic event on Venus is estimated to have occurred around 500 million years ago, leaving the planet's surface largely unchanged since then. This geological stasis has allowed the supercritical ocean to dominate the surface, creating a world where the boundaries between liquid and gas blur into a suffocating uniform haze. Speculation. If Venus once had a more Earth-like atmosphere, the transition to its current state may have been gradual but inevitable. The supercritical ocean, once a dynamic force shaping the planet, became a stagnant, oppressive blanket, choking off any possibility of life. The lack of water vapor in Venus's atmosphere, less than 20 parts per million, suggests that any early oceans of water were lost long ago, boiled away by the relentless heat or stripped away by solar winds. What remains is a world locked in a perpetual state of infernal stillness, a grim reminder of the delicate balance required for habitability. Interpretation. Venus, often called Earth's sister planet, due to its similar size and composition, serves as a cautionary tale. Its supercritical ocean, a product of unchecked greenhouse warming, offers a glimpse into a potential future for Earth if climate change is left unchecked. The stark contrast between Venus's hellish surface and Earth's vibrant biosphere underscores the importance of geological activity and atmospheric regulation in maintaining a habitable world. As we explore Venus further, its supercritical ocean may provide valuable insights into the limits of planetary habitability and the fragile nature of life in the cosmos. Part 5. A World in Stasis. Venus lacks a magnetic field which suggests its core may have solidified, halting the convective currents that drive plate tectonics on Earth. Without plate tectonics, carbon dioxide cannot be recycled into the mantle, leading to a runaway greenhouse effect that has left the planet shrouded in a thick toxic atmosphere. The consequences of this stagnation are stark. Venus has a surface temperature of 870 degrees Fahrenheit, 465 degrees Celsius, hot enough to melt lead. Its atmospheric pressure is 92 times greater than Earth's, equivalent to the pressure found nearly a kilometre beneath Earth's oceans. Yet, despite this seemingly dead world, radar images from Venera 15 and 16 revealed long rift valleys, volcanic features and ridges that hint at tectonic deformation. How can a planet without plate tectonics exhibit such features? One hypothesis is that the supercritical carbon dioxide ocean may have played a role, carving channels and shaping the surface over time. This unique state of carbon dioxide, neither liquid nor gas, could have acted as an erosive force, sculpting the landscape in ways that are difficult to fully comprehend. Another possibility is that Venus's interior is not entirely stagnant. Some observations suggest recent lava flows, indicating that the planet may still be geologically active. The Magellan spacecraft, for instance, detected over 1,000 impact craters on Venus, but also discovered extensive lava flows that appeared to have occurred after the craters formed, suggesting volcanic activity within the last 500 million years. However, these findings remain inconclusive, leaving scientists to debate whether Venus is truly a world in stasis or one with lingering geological vitality. The mystery deepens when we consider the atmosphere. Venus's clouds are composed of sulfuric acid droplets, and the planet experiences high-speed zonal winds reaching 100 meters per second at altitude. This phenomenon, known as superrotation, remains one of the most enigmatic aspects of Venus's climate. What drives this motion? How is energy transferred between layers? These questions remain unanswered, but recent research has begun to offer tantalizing clues. For example, the Akatsuki spacecraft, launched by Japan in 2010, has observed that the zonal winds on Venus are not uniform across all latitudes. Instead, they vary in speed and direction, suggesting complex atmospheric dynamics that may be influenced by factors such as solar heating or interactions with the planet's topography. Observation. The European Space Agency's Venus Express mission, which orbited Venus from 2006 to 2014, detected significant variations in the sulfur dioxide content of the planet's atmosphere over time. This gas, which plays a key role in the production of sulfuric acid clouds, has been observed to fluctuate by as much as 50% in just a few days. Such rapid changes suggest that Venus's atmosphere is far more dynamic than previously thought, with processes like volcanic eruptions potentially injecting large amounts of sulfur dioxide into the air. If confirmed, this could provide further evidence that Venus is not entirely geologically dormant. Interpretation. The presence of tectonic features, recent lava flows, and atmospheric variability on Venus challenges the notion that the planet is entirely inert. Instead, it may be in a state of slow, intermittent activity, with periods of geological quiescence punctuated by episodes of volcanism and tectonic deformation. This scenario could explain the observed features without requiring a fully active plate tectonic system. However, more data is needed to test this hypothesis. Speculation. If Venus does indeed harbour residual geological activity, it raises intriguing questions about the planet's habitability in the distant past. Billions of years ago, before the runaway greenhouse effect took hold, Venus may have had a more Earth-like climate, complete with liquid water oceans. Some models suggest that under such conditions, life could have emerged and persisted for hundreds of millions of years. While this remains purely speculative, it underscores the importance of understanding Venus's geological history to assess its potential as a once habitable world. In the end, Venus remains a planet of profound mysteries. Its thick clouds obscure more than just its surface. They hide the answers to questions about its past, present, and future. But with each new mission, from the Soviet Venera probes of the 1970s to the upcoming Veritas and Envision missions planned for the 2030s, we peel back another layer of the enigma. Perhaps one day we will finally understand whether Venus is a world frozen in time or one still shaped by the relentless forces of change. Part 6. The Search for Life. Could life exist on Venus? Not on the surface. The conditions are far too extreme. The surface temperature hovers around 470,000 degrees Celsius, hot enough to melt lead, and the atmospheric pressure is a crushing 92 times that of Earth's sea level. But some astrobiologists have proposed that life could thrive in the clouds, where temperatures are more temperate. At altitudes of 50 to 60 kilometers, the temperature ranges from 20 degrees Celsius to 40 degrees Celsius, and the pressure is roughly 1 bar, similar to conditions on Earth. Sulfuric acid droplets dominate this layer, but there's also water vapor, albeit at a concentration 100 times lower than in Earth's atmosphere. In theory, microbial life could survive in these droplets, using chemical energy from sulfur compounds or absorbing sunlight for photosynthesis. These microbes, if they exist, might resemble extremophiles on Earth, such as the acid-loving bacteria found in hot springs or mine drainage. The idea of life in Venus's clouds was first proposed in the 1960s by scientists like Harold Morowitz and Carl Sagan, who envisioned aerial microorganisms that could metabolize organic compounds and reproduce in the cloud layer. In 2016, Sanjay Lamai of the University of Wisconsin-Madison suggested that dark patches observed in Venus's clouds could be evidence of microbial colonies, absorbing ultraviolet light for energy. These patches, which can stretch for thousands of kilometers, remain unexplained by conventional atmospheric processes. In 2020, a team of scientists led by Jane Greaves of Cardiff University announced the detection of phosphine gas in Venus's clouds. On Earth, phosphine is produced almost exclusively by biological processes or industrial activity, primarily associated with anaerobic environments like swamps or animal digestive tracts. Its presence on Venus, if confirmed, would be difficult to explain without invoking biological sources, as no known chemical pathways could produce the observed quantities, estimated at 20 parts per billion. However, subsequent reanalysis of the data by other teams cast doubt on the detection, suggesting that the spectral signal attributed to phosphine could have been an artifact or misinterpretation. The phosphine claim remains unresolved, leaving the question of life on Venus an open mystery, but the search for answers continues. The possibility of life on Venus has inspired a renewed interest in exploring the planet, which has been largely overlooked since the 1980s in favor of Mars and the outer solar system. In the coming decades, new missions will descend into Venus's atmosphere, equipped with more sensitive instruments capable of detecting subtle chemical signatures. NASA's Da Vinci Plus mission, scheduled to launch in the late 2020s, will sample the cloud layer directly, searching for organic compounds and other potential biosignatures. The European Space Agency's Envision mission, planned for the 2030s, will map Venus's surface and atmosphere in unprecedented detail, helping scientists understand the planet's geological and chemical processes. These missions will also investigate Venus's past, searching for clues about whether the planet once had oceans. Billions of years ago, Venus may have been more Earth-like, with liquid water on its surface. If life emerged during this habitable period, it's possible that remnants persist in the clouds, having adapted to the planet's dramatic transformation. The fate of Venus serves as a cautionary tale for Earth, highlighting the potential consequences of unchecked climate change. As scientists probe deeper into Venus's mysteries, they may not only discover extraterrestrial life, but also gain insights into the fragility of habitable worlds. Observation. The clouds of Venus are a dynamic environment, with winds reaching speeds of up to 360 kilometers per hour. Any microbial life adapted to this habitat would need to survive not only the acidic conditions, but also the constant turbulence. Interpretation. The presence of unexplained dark patches and anomalous chemical signatures in Venus's clouds suggests that there may be processes at work that scientists do not yet fully understand. While these could be geological or atmospheric in nature, the possibility of biological activity cannot be ruled out. Speculation: if life does exist on Venus, it may represent an entirely independent origin of life in the solar system. This would have profound implications for our understanding of biology and the likelihood of life elsewhere in the universe. Alternatively, if Venusian life shares a common ancestor with Earth life, it could suggest that microorganisms were transferred between the planets in the distant past, perhaps via meteorites. Either scenario would redefine our place in the cosmos. As the next generation of spacecraft ventures into the inferno of Venus, they will carry the hopes and curiosity of scientists and dreamers alike. The search for life on our sister planet is more than just a scientific quest. It is a journey to understand our own existence and the potential for life beyond Earth. Whether Venus is a world of death or a haven for life in the clouds, its secrets will shape our understanding of the universe and our place within it. Part 7. The Legacy of Venera. The Venera missions stand as an achievement deserving greater recognition. Often overshadowed by NASA's Moon and Mars endeavors, these missions tackled unprecedented engineering challenges. Soviet engineers, working with limited resources and repurposed materials, designed cameras and pressure vessels to function in Venus's infernal conditions. Cameras were pre-cooled to 10°C to ensure they could operate briefly before succumbing to the 460°C surface temperature. Vessels were hand-welded to withstand 90 atmospheres of pressure, equivalent to diving 900 meters beneath Earth's oceans, but in a corrosive atmosphere of supercritical carbon dioxide. Every component was a testament to human ingenuity, crafted to endure conditions that would obliterate most technology. The Venera program embodied human ingenuity and resilience. Between 1961 and 1984, over 20 missions launched, each building on prior lessons. Early setbacks, such as Venera 1's communication loss in 1961 and Venera 3's crash into the surface in 1965, were treated as stepping stones rather than failures. Engineers meticulously analyzed each misstep, refining designs and strategies for subsequent missions. By 1970, Venera 7 became the first spacecraft to transmit data from another planet's surface, surviving for 23 minutes in temperatures exceeding 475 degrees. This milestone, achieved just a year after Apollo 11's moon landing, was largely overlooked in the West, but it marked a triumph for Soviet space science. Despite constraints, the missions achieved remarkable successes. Venera 13, for instance, drilled into 460°C volcanic rock amid supercritical carbon dioxide at 92 atmospheres. Its lubricants and mechanical systems functioned flawlessly, revealing Venus's surface composition for the first time. The spacecraft's drill penetrated 14 centimeters into the basaltic regolith, collecting samples that unveiled a landscape shaped by volcanic activity and weathering processes unlike anything on Earth. Venera 13's feat challenged existing geological theories, suggesting that Venus might have been more Earth-like in its distant past. The missions also advanced space communication. Engineers developed innovative antennas and algorithms to transmit data through Venus's dense atmosphere. In 1975, Venera 9 sent the first images from another planet's surface, capturing a rocky, haze-shrouded landscape that had never been seen before. These images, though grainy and tinted orange by Venus's atmospheric haze, provided an unprecedented glimpse into the planet's hidden world. Each frame was a triumph of engineering transmitted over 108 million kilometers to Earth using cutting-edge radio technology. The Venera legacy extends beyond Venus. Its technology laid the foundation for Soviet and Russian space endeavors, including the Mir station and Soyuz program. Lessons learned influenced designs for missions to the Moon and Mars, with innovations in thermal protection and data transmission still in use today. For example, the Venera lander's heat shields inspired designs for the Mars rovers, enabling them to withstand the intense heat of atmospheric entry. Similarly, the communication systems developed for Venera paved the way for more advanced data relay methods used in modern missions. The human stories behind Venera are equally compelling. Thousands of Soviet engineers, many working in secrecy, dedicated their lives to the program. Among them was the team at the Babakin Space Center, who handcrafted the Venera landers with meticulous precision, knowing they might never see the fruits of their labor. The program also fostered international collaboration, with French scientists contributing to the experiments aboard Venera 15 and 16. These partnerships underscored the universal appeal of exploring the unknown, transcending Cold War tensions. Observation, Venera demonstrated that even the harshest environments can be conquered with determination and innovation. Its legacy is one of scientific discovery and human achievement, turning Venus from an inaccessible inferno into a place where humanity could learn and leave its mark. The data collected by Venera missions continue to inform our understanding of planetary formation and the potential for life beyond Earth. Interpretation. The relative obscurity of Venera in Western narratives underscores the overlooked contributions of non-American space programs. While Apollo and Mars rovers dominate public consciousness, Venera's achievements deserve recognition for their technical brilliance and role in expanding humanity's cosmic understanding. The program's successes also highlight the value of perseverance in scientific exploration, as each mission built upon the last, gradually unveiling the mysteries of Venus. Speculation. With greater funding and support, Venera could have unlocked more of Venus's secrets. Often dismissed as a hellish wasteland, the planet might have revealed clues about its past habitability. Recent studies suggest Venus may have had oceans and a milder climate billions of years ago, making it a potential candidate for early life. Venera's legacy could inspire future missions to revisit Venus, building on the foundation laid by Soviet pioneers. By returning to this enigmatic world, humanity might uncover not only the story of Venus, but also new insights into the fragility of Earth-like environments. Part 8. The Future of Venus Exploration. NASA has announced 2 ambitious missions to Venus launching later this decade, marking a renewed interest in Earth's enigmatic sister planet. Da Vinci Plus, scheduled for 2031, will drop a sophisticated probe through Venus's thick atmosphere. During its hour-long descent, the probe will analyze trace gases, measure water vapor concentrations, and record temperature and pressure profiles with unprecedented precision. This data could provide critical insights into the planet's atmospheric dynamics and the mysterious processes that transformed Venus into a hellish world. Veritas, the second mission, will use advanced radar technology to map Venus's surface in far higher resolution than ever before. The orbiter will create detailed 3D relief maps, revealing geological features as small as a few meters across. These maps could unveil the secrets of Venus's volcanic activity, tectonic processes, and the possibility of past oceans. The European Space Agency, ESA, has also joined the effort to unravel Venus's mysteries with its Envision mission. Scheduled to launch in the early 2030s, Envision will carry a suite of instruments designed to study the planet's surface composition, internal structure, and atmospheric behavior. Using synthetic aperture radar, SAR, the orbiter will penetrate Venus's dense clouds to map the surface in extraordinary detail, while spectrometers will analyze the chemical makeup of the rocks below. Envision's data could help scientists determine whether Venus was ever habitable and what caused its dramatic climate shift. Meanwhile, Russia has been discussing the Venera D mission, a return to Venus that would include both an orbiter and a lander. If realized, Venera D would build on the legacy of the Soviet Venera missions, which achieved the first successful landing on another planet in 1970. But the real future of Venus exploration may lie in the cutting-edge technologies NASA is developing. Silicon carbide electronics, designed to withstand Venus's scorching temperatures and crushing pressures, could enable landers and even rovers to operate on the surface for weeks or months. These advanced electronics, combined with phase-change thermal systems that can regulate extreme temperatures, would allow for longer duration missions than ever before. Long-duration power supplies such as advanced radioisotope thermoelectric generators, RTGs, could provide the energy needed to sustain these ambitious endeavors. With these innovations, a seismometer operating on the surface for 60 days could detect Venus quakes, measure crustal movements, and determine whether Venus's interior is still molten and geologically active. A rover equipped with these technologies could traverse kilometers across Venus's rugged terrain, studying different rock types and searching for evidence of past water. Such a mission could answer one of the most pressing questions in planetary science. Did Venus ever have oceans? And if so, what caused them to disappear? The rover could carry instruments like X-ray fluorescence spectrometers to analyze the composition of rocks and soils, or ground-penetrating radar to peer beneath the surface and map subsurface structures. These tools could reveal whether Venus once had a hydrological cycle similar to Earth's, or if its evolution took a dramatically different path. In addition to surface missions, future Venus exploration could include aerial platforms, such as balloons or gliders, designed to float in the planet's upper atmosphere. At altitudes of 50 to 60 kilometers, the temperature and pressure on Venus are remarkably Earth-like, making it possible for such platforms to operate for extended periods. These aerial missions could study the chemistry and dynamics of Venus's atmosphere, providing insights into its complex weather patterns and the processes that drive its runaway greenhouse effect. They could also search for signs of microbial life in the clouds, a tantalizing possibility suggested by recent studies. Observation. The renewed interest in Venus is driven not only by scientific curiosity, but also by the urgent need to understand the processes that led to its extreme climate. As Earth faces its own climate challenges, Venus serves as a stark reminder of the potential consequences of unchecked greenhouse gas emissions. Studying Venus could provide valuable lessons for our own planet's future. Speculation. If future missions confirm that Venus was once habitable, it could revolutionize our understanding of planetary evolution and the conditions necessary for life. Venus, often dismissed as Earth's evil twin, might instead be a mirror reflecting both the fragility and resilience of worlds. Its story could inspire new approaches to climate science, exoplanet research, and even the search for life beyond our solar system. The next decade promises to be a golden age of Venus exploration, with missions from multiple space agencies poised to unlock the planet's secrets. From orbiters mapping the surface in unprecedented detail to landers and rovers braving the harsh conditions on the ground, these endeavors will rewrite the story of our nearest planetary neighbor. And as we uncover the truth about Venus's past, we may also gain insights into our own future. Part 9. The Warning. Venus may hold the key to understanding Earth's future. Computer models suggest that billions of years ago, when the Sun was cooler and Venus's atmosphere was thinner, the planet may have had liquid water oceans. Imagine a world not unlike Earth, with vast seas reflecting the light of a younger sun. The simulated past of Venus reveals a planet that was temperate, with surface temperatures potentially ranging between 20 degrees Celsius to 40 degrees, a stark contrast to its current scorching 477. If true, Venus was once habitable, at least in the sense of having liquid water on its surface. Scientists speculate that this habitable period could have lasted for up to 2 billion years, long enough for life to potentially emerge and evolve. But something changed. Volcanic activity may have released massive amounts of carbon dioxide, transforming the atmosphere. Or perhaps the sun's increasing luminosity, a natural process that will see it grow 10% brighter every billion years, evaporated Venus's oceans, leaving behind a dense, suffocating atmosphere. Another theory points to the lack of plate tectonics on Venus, which on Earth helps regulate carbon dioxide levels through the carbonate-silicate cycle. Without this mechanism, Venus was unable to sequester excess carbon dioxide, accelerating the greenhouse effect. Whatever the cause, Venus became the inferno we see today. Its atmosphere is now 96.5% carbon dioxide, creating a runaway greenhouse effect that traps heat with devastating efficiency. The surface pressure is over 90 times that of Earth, comparable to the pressure found nearly a kilometer deep in our oceans. Clouds of sulfuric acid reflect sunlight, making the planet appear bright and serene from afar, while concealing the hellish landscape below. Understanding what happened on Venus could help us avoid a similar fate on Earth. As our planet warms and carbon dioxide levels rise, we inch closer to a runaway greenhouse effect. Since the Industrial Revolution, Earth's atmospheric carbon dioxide levels have risen by nearly 50%, reaching over 410 parts per million, a number not seen in at least 800,000 years. The consequences are already visible. Global temperatures have increased by approximately 1°C. Since pre-industrial times, ice caps are melting at unprecedented rates, and sea levels are rising, threatening coastal cities worldwide. Observation. The Intergovernmental Panel on Climate Change, IPCC, warns that without significant reductions in greenhouse gas emissions, Earth could experience catastrophic and irreversible changes. These include more frequent and intense heat waves, storms and droughts, as well as the collapse of ecosystems and mass extinctions. The economic cost of inaction is estimated to reach tens of trillions of dollars by the end of the century, not to mention the human toll of displacement, poverty, and conflict. Venus serves as a stark reminder of how delicate the balance of life is and how easily it can be disrupted. Its transformation from a potential ocean world to a lifeless wasteland underscores the urgency of addressing climate change on Earth. As we stand on the precipice of our own anthropogenic climate crisis, The story of Venus is not just a cautionary tale, it is a call to action. Every decision we make today will shape the future of our planet and determine whether it remains a haven for life or follows Venus into a desolate, uninhabitable future. The choice is ours, and the time to act is now. Part 10. The Final Countdown. The last signals from Venera 13 and 14 faded out in 1982, leaving behind only the haunting silence of Venus's unforgiving surface. The landers are still there, slowly being corroded by the atmosphere, their once gleaming exteriors now dulled by sulfuric acid clouds that rain down with relentless fury. One day, perhaps a future mission will find them, ancient artifacts of humanity's first steps onto another world's surface. For now, they rest in the heat, the darkness, and the crushing pressure, monuments to human ingenuity and perseverance. Their cameras, which once transmitted grainy, sepia-toned images of Venus's rocky plains, are now lifeless, their lenses forever fixed on a world that remains both familiar and alien. Venus may be hell, but it is our hell. A world that challenges us, terrifies us, and yet, in its own way, inspires us. Its surface temperature, averaging 870 degrees Fahrenheit, 465 degrees Celsius, is hot enough to melt lead. The atmospheric pressure is over 90 times greater than Earth's, equivalent to being submerged nearly a kilometre deep in the ocean. Despite these extremes, scientists have proposed plans to explore Venus with advanced technologies, such as cloud-skimming airships or robotic landers equipped with advanced cooling systems. These proposals are not just flights of fancy, they are testaments to the human drive to understand the unknown. As we push the boundaries of exploration, we are reminded of the words of Carl Sagan. Somewhere, something incredible is waiting to be known. And on Venus, that something incredible may be the answer to our own planet's future. Venus, often called Earth's sister planet, due to its similar size and composition, offers a stark warning about the consequences of runaway climate change.